So in this video, I'm going to go over the 2022 fall semester midterm review. So here we go. So state the rules for the following transformations. We did this in Unit 1. So if it's a reflection over the x-axis, then the sign of y changes. So it's going to be x comma negative y. Reflection over the y-axis, the sign of x changes, negative x comma y. Okay. Reflection over the line y equals x, they switch positions, so it's going to be yx. And when it's reflection over the line y equals negative x, they switch and change signs. So it's going to be negative y comma negative x. Translation along the vector hk, this is going to be x plus h, because that's our x value, and y plus k. Rotation 90 degrees about the origin. Again, that's going to be going left from quadrant 1. So that's going to be negative y comma x. Remember, when it's 90 and 270, it's yx. When it's 180, it's just going to be negative x comma negative y. This time they just changed to the negative signs because it's, again, in the third quadrant. And here with the 270 degree rotation, again, it's going to be y comma, this time negative x. And it would be in quadrant 4 if it had rotated 270 degrees from quadrant 1. All right, so the next one says a figure has vertices k, l, m. After transformation, the image of the figure has vertices k prime, l prime, m prime. Identify the transformation. So I'm going to pick one of these that's uniquely different. So I'm going to use, let's see, I did k. Yeah, I chose k. So we're going to go from k, which is negative 3 comma 5, to k prime, which is 3 comma negative 5. So hopefully you can see what changes, just the signs of both, right? So the transformation is negative x comma negative y, and that is a 180 degree rotation. The next one says quadrilateral ABCD is rotated about the origin and then translated along the vector negative 2, 1. What are the final coordinates of the final image for point B? So point B is right here, and that is 5, 1. So we're going to start with our B, which is 5, 1. And then we are going to rotate it 90 degrees. So that means it's rotating over to here, right? So it's going to be negative y comma x. So that's the rule we're going to apply to our B prime to become B prime. So it means 1 comma negative 5. Whoa, wait a minute. Did that backwards. All right, let's write it again. B prime. So I'm just going to go ahead and write our 1 and then our 5. And notice that the 1 becomes negative, right? Okay, then it says we're going to be translated along the vector. And this right here, the rule here is going to be what? X minus 2 comma y plus 1. So now we're going to subtract 2 from our x and add 1 to our y. So our B double prime would be negative 1 minus 2 is negative 3. And then 5 plus 1 is 6, right? So that's going to be 3, 6. That's our B double prime. Then it says for number 4, quadrilateral ABCD is reflected over y equals x. Then it's translated 3 units down and 4 units right. What is the final coordinate of the final image of point A? So this time we're doing A. So our original A is 2, 1, right? Right there, 2, 1. Okay. So it says we're reflecting over y equals negative x. So that's going to be the rule negative y comma negative x, right? And then we're going to translate it 3 units down. So is that going to be a change in x or y? That's going to be a change in y, right? And then 3 units right. So that means we're going to actually add 3 to our x, okay? So this didn't say anything about an afterward, so we're going to do it in the order it's given. So for A prime, we're going to apply the negative y negative x. So it's going to be negative 1 comma negative 2 because they flipped and changed signs. Now we're going to add 3 to both to the x. So that for A double prime, that would be negative 1 plus 3, so that would be 2. And then for our y value, we're subtracting 3 from negative 2, so that would be negative 5. So that's our new A double prime to negative 5. So these next 3 ask to identify the transformation in the following images along with their rule. So what I'm going to do first is I'm going to draw me some lines from these vertices. And I'm already noticing that they are not the same length, but they are parallel. So what we want to do is cut them in half, right? So that's what I want to do right here. And that's going to be right there. So that looks to me like that is the line y is equal to x. Can you guys see that? So this is a reflection, and I know that because the lines are parallel. However, they are not the same length, right? So that tells me it's going to be a reflection over the line y equals x, okay? So our next one, again, we're going to connect our vertices. So we're going to connect B to B prime. That's not a very straight line, but y'all get it. C to C prime. Oh, they crossed. So we know that this is going to be a rotation, right? So this is going to be a rotation. So we want to figure out how far it rotated. Well, obviously it looks like it moved 2 quadrants. So just look at your C and your C prime. It went from quadrant 2 to 4. A went from quadrant 3 to quadrant 1. So this is a rotation 180 degrees, right? All right, here's our last one. We're going to go from M to M prime, N to N prime, and L to L prime. Again, notice these lines are parallel, right? But they are not the same length. So here again, we're going to cut these lines in half. We're going to bisect them, right? So that's going to be a reflection, again, because the lines are parallel, but they are not the same length, over what line now? This is going to be y is equal to negative x. You notice that line has a negative slope. It's falling from left to right. So our next one says, given EF is the angle bisector, ooh, key phrase, bisector of an angle, right, of DEG. So we're going to draw angle DEG. D, E, and G down here. And it says EF is a bisector, right? So that means that these two angles have to be congruent, because that's what bisect means, cut into 2 equal parts, right? It tells us that DEF is 3x. Oh, that's supposed to be a plus up there, y'all, and a plus right here. Okay, so this is going to be 3x plus 1, which means the bottom angle is also 3x plus 1, isn't it? And then it tells us the whole angle DEG, the big angle, is 5x plus 19. So it says find the value of x in the measure of DEF, DEG, and FEG. So to do this, we're going to actually add all these together. So we're going to add our 3x plus 1 plus 3x plus 1, which we could just multiply that by 2, and set that equal to our 5x plus 19, okay? So that's going to be 6x plus 2 is equal to 5x plus 19. So we are going to subtract 5x from both sides. That gives us x on the left, right? We're going to subtract 2 from both sides. So that means x is going to be equal to 17. Now what we must do is plug in that 17 into both of these angles and this big angle. So I'm going to do 3 times 17, that is 51. Plus 1, that's 52, and that's equal to the measure of angle DEF, which means that's also going to be what? Equal to the measure of FEG, right? Because they are equal in the same equation. So then what are we going to have to do to find the measure of the big angle? We could do one of two things. We could add 52 to 52, which is 104. So remember, this is 52 degrees here, and this is 52 degrees here, right? So that's going to be 104, but let's just check and make sure we got the right value for our x, okay? So 5 times 17 plus 19 is, guess what? Yep, 104. Okay? Good way to check it. The next one says, given the figure DEF, and it gives us the points, the figure is reflected over y equals x, then translated 3 units to the left and up, 2 units up, okay? So this time we're reflecting over y equals x, okay, so that's the rule what? Over y equals negative x, so negative y comma negative x. Then translated 3 units to the left, so that's going to be x minus 3 and y plus 2, right? So again, doesn't have the word after this time, so you need to be watching for that word, okay? If the word after is there, then you're going to flip the order, okay? So in this case, it's not there again. So in this time, it's asking us for D. So D is 2 comma negative 5. So we are going to reflect it over y equals x. Y equals negative x first. So our D prime, we're going to do this first, y'all. So that's going to give us what? A positive 5 and a negative 2. Now we're going to subtract 3 from 5. So our d double prime would be 5 minus 3. So that's going to be 2. And then we're going to do 2 minus 2, which would be 0. So our answer here for d double prime, is 2, 0. The next one says using the following triangle to find the value of the measure of ACD, ACB, and ABC. So if you recall, because we have an isosceles triangle here, our base angles at B and at C are congruent, right? So because they're congruent, we're going to take our 180, because all of those added together should equal 180. We're going to subtract from that 72. Okay, and that's going to give us 108. And then we're going to take that 108, because these two base angles are the same, we're going to divide it by 2. That's going to give us 54. So that means these angles down here are 54 degrees and 54 degrees. So that means there's 2 ways I could solve for the exterior angle. That is this angle out here, right? This angle out here, ACD. So the measure of angle ACD, we could add 72 plus 54. And if we were to do that, we would get 126. We could have also done 180 minus the 54, right? Which would have also given us the 126. So I don't care which way you do it. You could do it either way. And then it's also asking us about angle ABC. The measure of angle ABC is this angle right here, right? So that's equal to 54. And then it also asked us about this one, right? ACB. So the measure of angle ACB is equal to 54 as well. Okay? All right, the next one says supply the missing reason in the proof that AB bisects DE and BD and bisects AB and DE. Okay, so that first thing says AB bisects DE. AB bisects DE. So it means that's going to be the same length as that, right? Because if it bisected, it cut it into 2 equal parts. AB bisects DE and BD is, I think that's supposed to be, and BD is parallel, y'all, to AE, because that's what's given here, okay? So what does that mean? That means that if BD and EA or AE are parallel, then we have a pair of congruent angles here, right? And those are congruent because of alternate interior angles theorem, right? And then it also keeps going down through here, and it says BCD, that angle right there, and ACE, that angle right there. It's basically asking us, why are those 2 angles, these 2 angles right here, why are they congruent? Because they are vertical angles. Okay, that's why. And hopefully by now you guys can see that. Number 10 says, based on the diagram, what marking can be added? Obviously vertical angles, right? Could be added. Those are always congruent. Then it says, what additional information is needed in order to show that ABC is congruent to triangle EDC by side angle side? So wouldn't that mean we'd need another pair of sides? It's side angle side. The angle has to be between the sides, right? So that means we would have to say that, okay, first of all, let's say why we said that. We said that angle BCA was congruent with angle DCE because of vertical angles, right? And then we're going to say that AC has to be congruent to EC for us to be able to prove that these triangles are congruent by side angle side. Number 11 says, explain how you know the triangles are congruent and then solve for x. Okay, we have another pair of sides right here. So the shared side is congruent, right? So they are congruent by side, 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 right? Then it says solve for, so we know that we got that one tick side 7.5 is going to be equal to the 1.5. Oops, that's a really ugly 5, y'all. 1.5 plus 2x. So we're going to subtract 1.5 from both sides, right? So that's going to give us 6 over here is equal to 2x. So this would mean x is equal to 3 because we're going to divide both sides by 2. Number 12 says, using the graph to do the following transformations, a rotation 90 degrees. Ooh, there's that word, after. After a translation of 3 units up and 2 units left, what would the final coordinate of B be? Okay, so B's original B is -2, 1. So this time it's saying we're doing a 90-degree clockwise rotation. So that would be, so this right here would be what? Clockwise is down here, right? Okay, so that's going to be y, comma, -x, and that's going to be the second thing that's going to happen, right? Because it says that that happens after the translation of 3 up and 2 left, okay? So if we're going 3 left, x minus 3, 2, wait. Ooh, I almost made the mistake that y'all make. Good mistake, Michelle, to catch. 3 units up, so that's going to be a y plus 3, right? And this is going to be an x minus 2. Don't make that mistake on this exam, y'all, okay? So now we're going to do our B prime, okay? Actually, let's do it in blue because that's what we have to do first, right? This is our first step, yes? Okay, so our B prime, we're going to subtract 2 from -2. That's going to give us -4. And then we're going to add 3 to 1, which is going to give us a +4, right? So now we're going to do our B double prime. Okay, so now we're going to flip them. So our y becomes our x, so that's going to be our 4. It moves to the front, but then the x changes sign, so our answer is going to be 4, 4. Okay. So on this next one, it says, can you prove the triangles are congruent? If so, write a congruent statement for the parts that are congruent, and then write triangle congruent statement and tell why they are congruent. So the first thing I'm going to mark is the shared side, because I know it's congruent. Then notice that we have a pair of parallel sides, right? So we have QR up here. Let's just do this, QT and RS, okay? So now watch this. This is the line that intersects those two. So where does the green intersect the blue? There and there. Y'all see that? That's how we can see where our alternate interior angles are congruent, right? So we can say angle QTR is congruent with what angle? So now I started, so it's going to be SRT, right? Okay, so watch that, all right? So then we also have another pair. Can you guys see this other pair of parallel lines right here, right there? See that? And that? So again, we're looking where do those intersect the green line? So it's here and here. So we're going to say another pair. So this is going to be angle QRT is congruent to angle STR. Okay, now both of these are congruent. Why? Because they're alternate interior angles, right? Which now you should be able to see. Look at the top triangle. Notice we were going to move from one thing to the next. Angle, side, angle. Y'all see that? So we can say that triangle QRT is congruent with triangle STR. Now look, I went from Q, which had nothing, to R, which had 2, to T, which had 1. So on the bottom, we're going to go from nothing to 2 to 1. Okay, and why are they congruent? We just talked about it, because it's angle, side, angle, right? All right, so what additional part would you need to prove that triangle DEC is congruent to BAC? Well, on this one's a little different because we have our vertical angles, right? These are congruent. And then once again, I'm going to show you guys because of these parallel lines right here. So we have a parallel line there and there, right? So look right here. We have this line is intersecting both of those. We have an angle up here that's congruent at E and an angle at A, right? And then also we have another angle at D and an angle at B that are congruent, okay? So it's saying what additional part would you need to prove that triangle DEC by angle, angle, side? Truthfully, angle, angle, side, if we want angle, angle, side, then we could say CE would have to be congruent. Again, angle, angle, side, so we would go angle, angle, side, right here. It'd have to be that side, right? So CE would be congruent to what? AC, right? For that one. Or We could go the opposite direction, couldn't we? So if we went angle, angle, side, it could be DC. Has to be congruent to what? BC. You got it. Okay, now on the other one, for angle, side angle, this one, honestly, it could be any side, literally. It could be any pair of sides. So it would be these two up here that we have, but then the third one would be what? We would also say that if it was DE, would have to be congruent to what? DE congruent. Okay, we went from 3 to, okay, so BA, right? There you go. All right. So number 15 says, what additional information would be needed to prove that triangle TAR is congruent to angle GAR by HL? Well, I would say we could have a right triangle there. So in right angle, not triangle, right angle, either at angle TRA, or couldn't it also be over here? Either one of those, because if one exists, then the other one has to. Or angle GRA. All right, here's our last two. It says TV, TW, and WV are midsegments of angle triangle DEF. DE is 3x plus 1. BC, actually, this should be VW, y'all. VW. I don't know why that said BC is x plus 3. TW is equal to 9. EW is equal to 6. Okay, TW. EW is equal to 6. Okay. So let's go ahead and just replicate what we have here so that we have all of those. So that if EW is 6, then WF is 6, right? And this whole thing would be 12, and this also would be 6, right? Remember, sides that are parallel are going to be the same length as half of the side it's parallel with, okay? So for this 9, because we have 9 here, we have 9 there, we have 9 there, and this whole side would be 18, right? Now, let's think this through. There's two ways we could do the relationship between ED and VW, but this is the way I'm going to suggest you do it. 3x plus 1, isn't that equal to 2 times x plus 3? I think that's going to be easier than taking half of things. Y'all got me? Because if I have this is going to be x plus 3 here and x plus 3 here, right? So that's why I'm setting it up this way. And it's going to be equal to the whole thing, okay? So that's going to be 3x plus 1 is equal to 2x plus 6. Subtract 2x from both sides. So that's going to give us x, and we're going to subtract 1 from both sides. So x equals 5. Now we got to plug that 5 back in, right? So for this length right here, 5 plus 3 is equal to 8, right? So that means this is 8, and that's 8, right? Let's do it in a different color, y'all, just so it's not so confusing. 8, red, 8. There we go. That's 8, and that's 8. Which 8 plus 8 is what? 16. And the way we could check that is 3 times 5 is 15, right? Plus 1 is 16, okay? So now you should know all of your lengths, right? So let's go ahead and write them over here. DE is 16. And then we've got VW is 8. And what was the other one? ET. ET is equal to 8. And DT is, TD is equal to 8, right? So all of those are related to each other, aren't they? Okay, then we've got DV. Let's do this in a different color. DV. Actually, let's do that one in blue because that's what color it is in the drawing. DV is equal to 9. Then we have VF is equal to 9. And we have DF is equal to 9 plus 9, which is 18, right? All right, and then our last one is TV is 6, right? TV is equal to 6. And then WF is equal to 6. And then what is EF? The whole length. EF is equal to 6 plus 6, which is 12. Okay? All right, last one, y'all. AD, CR, and BS are medians of triangle ABC. So that means we have this if we have the whole length, we divide it by 3, right? And then the shorter part is one part of that, and the bigger part is two parts of that. We're going to talk about what that means a little more in just a minute. So, but we're going to label stuff. So it says AM here. AM is 10. So if we divide that 10 by 2, so if we divide this by 2, we cut that part in half, then that means this part down here is half of that, right? So that's 5. Okay? And the whole length would be 15 then, right? You add them together. Then it says CR. CR. This time we have the whole length, right? So remember we said if we have the whole length, we're going to divide it by 3, right? So that means the smaller part down here is going to be 5. And again, these are two parts of 5, 5 and 5, which is what for this whole part right here? Isn't it 10? Y'all see that? Okay. Then we have that SM. This is our smaller part down here. So SM right here. Oops, let's change that to red. Yeah, okay, change for me, please. Okay, there we go. SM is 10. So again, remember, this is two parts of 10, right? So this part right here is 10, and that part right there is 10, because we've cut it in half, right? So that's 10 plus 10, so that part right there is 20, which means the whole length is 30. Okay, so let's just figure this out then. MD, so we got MD, it's in green. MD, right down here, MD is 5, and then we have AD, which is the whole length. AD is going to be 5 plus 10, which is 15, right? Sorry, that's supposed to be a D, y'all. I don't know why it looks like a B, but because I can't write today. Then we've got MB. MB's in red. It's right here, and we got 10 plus 10, right? So that's 20. So MB is equal to 20. And then we have SB, which is, SB is the whole length, right? So we're adding 10 plus 10 plus 10, so SB is equal to 30, right? 10 plus 20, or 10 plus 10 plus 10. And then we've got CM. CM is 5 plus 5, so CM is equal to 20. No, it's 10, sorry. 5 plus 5 is 10, not 20. So y'all, CM's right here, right? See it right there, CM? And then we have MR right here, MR, which is 5. MR is equal to 5, okay? All done? So I'm going to remind you guys that you should go back and look over all your quizzes from this unit, quizzes 1 through 6, because if there's anything there that we went over with our quiz talks, it might assist you in getting things correct on this midterm, okay?